It looks like it went away again. Can you see the thing, Lily? Can you see the review? Okay, so for numbers 1, 2, and 3, the way that we handle these are the segment addition postulate, okay? So remember, segment addition postulate was the part plus the part equals the whole. Well, on these, we're solving for x. So when you look at the information for what it gives you, you can see down here, this is the information it gives you. Well, this one here is the whole length, okay? It includes everything. So then we just have to kind of figure out how to set it up, okay? So when we look at this, we have 8 and then 14, but see, those kind of overlap here at this area, right? So we would have that area in there twice. So what we need to do is set it up where we say 7x minus 3, which is the whole thing, okay, equals 8 plus 14. And then since we have this area in there twice because it's included in the 14 and the 8, let's subtract that 1 plus x out. So we'll say minus, sorry, hold on. We'll say a minus 1 plus x, like that. So now when we process through that, we can combine our terms. So if you do this, first thing you have to do is distribute this negative in where we're subtracting that. So you're going to have 8 plus 14 minus 1 minus x, okay? And that equals 7x minus 3. Now when you combine your terms, 8 and 14 are 22, and then minus 1 is 21. So over here you have 21 minus x equals 7x minus 3. Now we're going to bring the we're going to bring the x over. So plus x here, plus x here. So you're going to have 8x. And then we need to move that 3 over also so that we get the x by itself. So we're going to add 3 to both sides there. So plus 3 here and then plus 3 here. So you get 8x equals 24. Divide both sides by 8 and x equals 3. Does that make sense? Okay, good. Now, that's going to be how you're going to handle 2 and 3 also. And then for 4, 5, and 6, you're going to, well, you'll kind of set those up similar. You just don't have that double part, okay? So for 4, 5, and 6, the difference is that you're solving for an actual length. So you're going to have to plug that x value back in. Number 4, Madison. Okay. Okay, so looking down here at number 4, again, these are the segment addition postulate, okay? So you have x plus 33 is the whole length there. And we're going to solve just for this part, for FE. So in order to do that, we have to find out what x equals. So the segment addition postulate, remember, says the part plus the part equals the whole. So we know if we add x plus 19 plus x plus 20, plus 3, that's going to equal x plus 33 because it's the part, and that equals the whole thing. Okay? You good with that so far? Okay. So now what we're going to do is just combine like terms and solve for x. So when we do this, we've got 1, 2, x is over here. And then with your terms, you have 19, 20, and 3. So those add up together to be 42. And now you're going to have to subtract x from both sides. Okay, so 2x minus x just gives you x. And then you also need to move that 42 over. So we're going to subtract 42, which is the opposite of what's being done. So 33 minus 42 is going to give you a negative 9. So you have x equals negative 9, but you're not done because it wants you to find FE. So FE equals x plus 20. So negative 9 plus 20 equals FE. So then that means 11 equals FE. Okay, good. Okay, so how do you have it set up, Lily? Okay, so it's not just minus 15 plus 2x. Remember how on that first one, we had to distribute that negative in for subtracting? So for that one, you're going to have, for number 2, you're going to have 19 equals x minus 3 plus 17, and then it's going to be minus, and then parentheses, negative 15 plus 2x. And then you have to distribute that negative in. So it'll be I'm going to write down here just because I'm afraid I might run out of room. X minus 3 plus 17 minus 15 plus 2x. Okay. And then you have to distribute this negative in. So that's going to become x minus 3 plus 17 plus 15 minus 2x. And that's probably where you're getting caught up at. Okay, you're welcome. Now, one thing I didn't check on these review packets before I handed them out, where it says find the measure of the angle indicated in bold, are you guys able to actually see that one of them is bolded and the other one is kind of grayed? Okay, good. I know sometimes it looks fine on the original, but whenever we copy it, it does not carry over. So let me scroll down to that. Okay, so this, Madison, is going to go, you're going to have to figure out the relationship that those angles have. What types of angles? So flip back in your note cards until you see, or if you can remember, when you have two angles that are in the same position in relation to the transversal. Do you remember what kind of angles they are? Okay, hold on just a second. Okay, Madison. So remember we had these hanging on the wall when we did our dance transversal thing? Look at this and see what type of relationship those two angles have. Well, alternate interior, one's on the right-hand side of the transversal and one's on the left-hand side of the transversal. These are both on the same side of the transversal, okay? So now they are in a different position than they are in this picture. But if you look, see this red angle here and this red angle here? They're both in the same position. They're both on top of the parallel lines and on the left-hand side of the transversal. So these angles in number 15 are both on the bottom and on the left-hand side, okay? So those are corresponding angles. And then corresponding angles we have to know are congruent. So when you set that up, you're going to have 17x plus 2 is equal to 16x plus 6 because they're corresponding. And since they're corresponding, they're congruent. So then you're going to solve for x. Okay, good. Solve for x and don't forget to plug back in. No, Lily, number 17, those two angles are both on the same side of the transversal and both inside. So those are called consecutive interior angles. And consecutive interior angles are supplementary, or they add up to 180 degrees. Yes, it's 85 for number 17. Oh, sorry, Lily. Hold on. Number 15. Yes, the answer is 70. Okay, Madison, number 19 is the midpoint formula. Okay, midpoint formula. Let me scroll down to it. The midpoint formula, remember, is taking the average of your x's and the average of your y's. So you're going to have to figure out what those coordinates are of those two endpoints, okay? So when we do that, this first endpoint up here is going to be your x's first, okay? So you'd go over to -1 and then up to 2. So the coordinate for that point is -1, 2. And then this point down here, we didn't go over any, so our x part is 0. And our y coordinate, we went down 1, 2, 3, 4 to -4. So it'll be 0, -4. And now you're going to add your x's together. So -1 plus 0 divided by 2. And then add your y's together. 2 plus a -4 divided by 2. So you end up with negative 1/2, and 2 plus a negative 4 is 2 minus 4, which is negative 2 over 2, which is negative 1. Okay? Okay, Devin, so good call. Number 23 is a little bit different because it gives you an endpoint and a midpoint, and you have to apply the midpoint formula, okay? Let me see if I can use a different tool for this. Okay, so for number 23, we have our endpoint of 5, 3. Oh, I forgot this one does not like to write my 3's. And then our midpoint of 6, 0. So remember, our midpoint formula is the midpoint equals x1 plus x2. That's a 2, even though it doesn't look like it. Divided by 2, comma, y1 plus y2 divided by 2. Okay? So what we have up here is we have an endpoint, right? And then we have the midpoint. So this number is going to actually get plugged in for this part. So let's break this formula into our two parts. To find the x coordinate of our midpoint, we use this part, okay? And the x coordinate of our midpoint is 6. So we're going to say 6 equals x1 plus x2 divided by 2. Well, we have one of the x values here, which is 5. So we're solving for the other x value. So 5 plus x divided by 2. And if we solve that, since we're dividing by 2, we have to multiply both sides by 2 so that we can move it over. So 2 times 6 is 12. And then we're going to have to subtract 5 from both sides. So we're going to get 12 minus 5 is 7. Okay. Now for the y, we're going to do the same thing. Our y value is 0. Okay. So 0 equals y1 plus y2 over 2. So our y2 is here at 3. So we're going to say 3 plus x divided by 2. So now we multiply both sides by 2. That cancels out. 2 times 0 is 0. So we get 0 equals 3 plus x. Oh, sorry, we already did the divided by 2. Now we have to subtract 3 from both sides, right, to get x by itself. So that's going to give us negative 3 equals y. So our new point, or our end point, is going to be at 7, negative 3. Does that make sense, Devin? You're welcome. Okay, Isabel, for 2 and 3, let me cast the problem up there. All right, so for 2 and 3, you're going to have to look at the diagram and see all of the information that it gives you. So you're solving for just x, okay? So for here, we know that the whole length on number 2 is 19, okay? So we're going to start with that, 19 equals, and then see the other information that it gives us. It gives us this x minus 3 and this 17, and we can see that this portion here is doubled, okay? Like it's in there twice because it's included here and it's included here. So if we subtract that out, that negative 15 plus 2x, subtract it out one time, then that will mean it's only included once, okay? Does that make sense? Okay, so when you set it up, you're going to have x minus 3 plus 17, and then to subtract it out, we're going to say minus and have to put in parentheses negative 15 plus 2x. And then we're going to have to distribute that negative in to both of those terms, okay? So what we're going to get is x minus 3 plus 17 and then plus 15 minus 2x, and that equals 19. And then you're going to combine your like terms and solve for x. Does that help? Okay, good. So Madison, number 7, it's a little wonky looking because you have this other transversal over here, because you have this one. So kind of block that out and only look at the other side of it, okay? Only focus on this part here. So what you have is two parallel lines cut by a transversal. So again, you have to figure out what the relationship is between this angle and this angle. So do you remember what type of relationship those angles have? Yes, that's right. Those are alternate exterior angles. So alternate exterior angles are congruent. So if this one is 112, then that means this one is also 112. Does that make sense? You're okay, Isabel. So for number 3, let me erase some of this. Okay, for number 3, we have to look at the information that it's giving us again. And for this one, we're just solving for x. So if we know, well, first, what's the whole length of that segment? Okay, 26. So if the whole length is 26, we're going to start with that. So 26 equals. Now, we can see that the segments, or that it's broken up into parts, okay? And if you notice, this one here and this one here kind of overlap. So this area is what's in there twice. So if we say 26 equals 4x plus 4 plus 7x minus 2, that includes this area 2 times. So we're going to have to take that area out once so that it's only in there 1 time. Okay? Does that make sense? You're welcome. So then you're just going to go through that and solve for x. Okay? On this one, you didn't have to do the whole parentheses thing that you did up here because it's just a -9. If it was more than one term there, though, you would have to distribute that in.